able to capture a very good variety of particles. These are pegs which are 5 micron spacing, just about the size of the larger Mars particles that we'd be looking for. And of course we're very eager now to zoom in probably another factor of 40 times, so we can extend that animation a little further, Peter, in a week or so, and see not just what the particles look like as maybe a little fuzzy blob, but we'll be able to, we hope, look down at the detailed substructure of those particles and actually see below the resolution of our optical microscope. Okay. We now have Mark Lemon, who is going to be talking about what the stereoscopic imager has been producing from its look around the lander.
Thank you. The Surface Stereo Imager has been very busy every sol, helping to contribute to making Phoenix a success. The camera is a tool both for helping to guide operations. It provides sort of our hand-eye coordination. It helps us pick where to use the arm, what to do, how to sample. And it's the way that we survey the site and connect what we see to other things that we know. Peter and Tom showed examples of some of the images that SSI has taken in the course of guiding the operations. I'd like to show one more example. This animation came down today, earlier in the day, Sol 18, and it shows the robotic arm poised over the trench at the commencement of digging operations, and as this animation plays, it will... I'm sorry, I'm waiting for the animation to actually play. The animation, the dig occurred in 3 parts over the day. The Sol 18 was our first serious dig, actually using the RA digging commands as opposed to the sample acquisition commands. And those commands were issued 3 times in the course of the dig over a 2-hour period. During each of those 3 digs, the SSI took 7 images spaced out over the dig. So I think we'll just be able to show you later what is happening in the trench during that time. We use that to monitor how the trench evolves over the course of the dig. What stuff do we uncover and then bury? How does the ice change its appearance once the digging is over? I'm sorry, I shouldn't say ice, the bright material. And I think what we see in the animation is very intriguing, and in particular at the end here we see a fairly stable look to it. There are very, very subtle changes related to the changing illumination, but no other strong variation. And you can see that the RA is just whizzing by in some of these frames, so you see it blurred a little bit. So this is a very dramatic way, I think, to visualize what's going on Mars, what went on Mars just a few hours ago. So SSI, in addition to its operational role, is our tool for surveying the landscape. It's the camera that can sit back, look at everything in color. It has human-like depth perception. So we have been taking advantage of that and acquiring our high-resolution color pan. And I'd like to show you the scene that we saw on Sol 16. This is looking at the landscape toward the west. We use images like this to understand the landscape as a whole. We can zoom out to the horizon and see distant features that are observable from orbit. You can see the hills fading into the dust in the background, as well as a small number of large rocks. That is exactly what we expected to find in the area that we were targeting for the landing. You can see some of the polygons in the distance as we pan closer to the camera, but then this also connects us to the stuff that we're actually sampling. So you see here in the scoop, the sample that on Sol 16 when this picture was taken was just about to go into the microscope. So the dirt that you're seeing there is the dirt that Tom just showed in the microscope. And that's the robotic arm camera poised looking into the scoop there, and the very slightly dusty solar arrays at the bottom of the screen. So a successful mission really requires understanding the context for all of the observations that we take. We are acquiring samples, putting them into the instruments, and coming up with a detailed understanding of a very small part of Mars. With the images, like the next one is another example, we can connect these small-scale observations to a larger scale. So this is showing a view to the southeast, and we can zoom in and see the kind of detailed features in our landing site. The rocks here have a very blocky texture. Just as a reminder, Phoenix landed in an area that was affected by the impact that created the Heimdall crater, and you're seeing relatively smaller rocks, rocks up to ballpark of a foot across. We're not seeing the large boulders that we saw at other places that caused us not to land there. The rock in the right-hand side there, Toto, is very interesting to me with its flat top, sort of an icebergy appearance, although it is a rock. And then as we pan out, we get to connect to the site as a whole. This is where we start seeing some of the troughs. We see the rocks just perched on top of the surface there. And going further and further out, we're still seeing mostly smaller rocks mixed in with the polygons until we get to the greatest distances where we can see the horizon. We start seeing two larger boulders there. Essentially, we expected to see boulders of the meter-plus scale, about one per baseball field in terms of size. And then at the far upper right-hand side, you see a bright glint. That is actually the back shell. You see the gold foil on the inside of the back shell that helped us land here. One interesting thing about that is if you look at the back shell closely, there is no parachute visible. While the parachute is clearly visible from orbit, the parachute must be lying in one of the troughs and hidden from our view. It'll be interesting to see if the wind blows it around any, if it ever shows up from our point of view. The next panorama I want to show is part of a complete set that we're trying to take. Ultimately, we will have a 360-degree view of our site in full color and using our binocular vision, using both eyes of SSI. This one is particularly important because this section, which was taken in the evening of Sol 14, actually comes up near our workspace. So you're looking essentially 10 feet away from the lander right now, just beyond Humpty Dumpty National Park. And as we pan across, we'll actually be coming up onto the area just behind Humpty Dumpty itself. Right now, we actually started just past where the trench is. And then as we go down, or as we continue to go across, we'll get into an area which connects up with Sleepy Hollow. So we're connecting the polygons and the troughs that we're seeing in the broader site with the ones in our immediate workspace. So I want you to imagine now standing, crouching in this area that we're looking at. One of the things that we can do with SSI is not only take color images, we can take stereo images. We take advantage of the camera's binocular vision, and we can use our depth perception to model the landscape. So the next graphic shows the landscape modeled. Right now it's only in black and white, but it shows this small section of Mars, and we're actually crouching down where we were just looking before in the color panorama and kind of turning our head around. You can see some of the polygons and troughs, the little hilly texture that you see. These are only about 8 inches tall, but if you sort of imagine yourself crouched down, they start to look a little more dramatic and impressive. I think this view is excellent. This is the sort of thing that we're trying to build up for the whole site. By the next week or two, we should have completed our mission success panorama, the panorama that we want to take to show from the spacecraft out to the horizon in full color and stereo, so that we can show an image like this, only in color, and fly around the entire landing site. So that's something that we're about halfway done with right now. We started on Sol 13, and through about Sol 18, we're about halfway done. So now, the last thing I want to mention that SSI does, we've been spending a lot of time looking up at the sky. SSI helps with the weather monitoring. There's a lot of dust on Mars, and we're measuring the amount of dust in the sky, and we're measuring the winds and seeing how the winds are blowing the dust around. And to talk more about the weather and how we're looking at it, here is Milton.